Hello viewers, in today's session we are going to discuss another important problem from differentiation, right? And in this class we are going to find out the derivatives of inverse function, right? So let us discuss this problem in which we are given a function f which is from n to range, that is n is the set of natural numbers. So the domain of the function f is the set of natural numbers, and here the range is r1, and this function f is invertible, and if g of x is the inverse of this function f of x, which is equal to 9x square plus 6x minus 5, then we have to find the derivative of the inverse function, that is the g of x, right? So we have to find g prime of 43 and g double prime of 43, right? Where g of x is the inverse of the given function f. So here we are given a function, say y is equal to f of x, that is 9x square plus 6x minus 5, and g of x is given to be the inverse of this function f, right? So g of x is equal to f inverse of x, right? So the function f of x is given to be invertible. It implies that the function f of x is a bijective function. So f of x is bijective, so it implies that f of x must be a 1 1 and onto function, right? Okay, so now here g of x is given to be the inverse of the function f of x, and we have to find the first derivative and the second derivative of the inverse function, right? So it means we have to find g prime of x and g double prime of x, where x is the input is given as 43. So now let us quickly discuss this function f of x. So here we have the set of natural numbers. Here we have the set of range, and the function is given as from n to r1, right? So the inverse function is from r1 to n, right? So this is f inverse, that is equal to g, right? So when we have x in the set of natural number, then here we have y, that is the image of x under f is y. So we can write y is equal to f of x, right? So when we take the inverse function, that is f inverse, which is equal to g, then g is from r1 to n, right? So g of y, the input is y here, so the image of y under g is given as x. So now let us derive an expression for g prime of x, that is the derivative of the inverse function. So now let us start with this expression, that is g is equal to f inverse, right? So we can now write g of x is equal to f inverse of x, and this can be written as f o g, that is the composition of f and g when we have the input x is equal to x, right? So the composition of the function and its inverse is equal to x, right? That is the identity function. So now the composition of f and g can be written as f of g of x, and here we have the identity function x. Now differentiating both sides with respect to x, we have d by dx of f of gx, and here we have d by dx of x, right? So now to differentiate f of g of x, we have to make use of chain rule. So first we'll differentiate f of g of x with respect to g of x. So here we have g of x, and here we have f of g of x, and then by chain rule we differentiate this function, that is g of x with respect to x, and here the derivative of x is 1. Right now, see, the derivative of f of g of x with respect to g of x can be denoted as f prime of g of x, and here the derivative of g of x with respect to x is g prime of x, and this is equal to 1. Right, so here we can see that we have the derivative of the inverse function, that is g prime of x. So g prime of x can now be written as 1 over f prime of g of x. So the expression for the derivative of the inverse function, that is g of x, is given by g prime of x is equal to 1 over f prime of g of x. Right, so we can use this expression to find out the value of this expression, that is g prime of 43. So now to derive the expression for the second derivative of g of x, that is g double prime of x, what we will do, we'll differentiate this equation both sides with respect to x. So differentiating 1 with respect to x both sides, we have d by dx of f prime of g of x, and here we have g prime of x, and the derivative of 1 is 0, being a constant. Right, and here now we have the product of two functions. So here we have u and here we have v. So we can use the product rule for differentiation, and this is equal to u dv by dx, and here we have v and du over dx. Right, so here we can now use this result. So we have f prime of g of x, and then the derivative of g prime of x, and plus v is g prime of x, and the derivative of f prime of g of x, and this is equal to 0. Right, so now we can write f prime of g of x, and here the derivative of g prime of x can be written as g double prime, because this is the second derivative, and then we have g prime of x, and here we can again make use of the chain rule. So first we'll differentiate f prime of g of x with respect to g of x, and then by chain rule we can write here the derivative of g of x with respect to x, and here we have 0. Right, so now this expression can be written as f prime of g of x, and here we have the second derivative of g of x, and here we have uh, g prime of x, and here the derivative of f prime of g of x with respect to g of x is f double prime, and here we have g of x, and the derivative of g of x with respect to x is denoted by g prime of x, and this is equal to 0. So now let us rearrange the terms here. So we have f prime of g of x and g double prime, and then here we have g prime of x and g prime of x. So multiplying these two together, we have the square of g prime of x, and then we have f double prime, and here we have g of x, and this is equal to 0. So now taking this term to the right hand side, we have f prime of g of x, g double prime x, and here we have negative of g prime of x square and f double prime g of x. So now we can write g double prime x is equal to minus, and here we have g prime of x square f double prime of g of x divided by this term, that is f prime of g of x. So this is the expression for the second derivative of g of x, where g of x is the inverse of the given function f of x, right? And we can also express this result in some other forms also. So let us see. So now if we replace f prime of g of x by 1 over g prime of x, because from this equation we can write f prime of g of x is equal to 1 over g prime of x. So replacing this term by 1 over g prime of x, we can also write g double prime of x is equal to minus, here we have g prime of x square, this is f double prime g of x, and here we have 1 over g prime of x, right? So now we can take g prime of x to the numerator, so it get multiplied with this one. So we have g double prime of x is equal to minus g prime of x, here we have cube, and then we have f double prime and g of x. So this is another important form of this result. So now there is one another form of this expression. So now if we replace g prime of x by 1 over f prime of gx in this expression, right? So what we will get, we have g double prime of x, and here we can now write minus, and g prime of x can be written as 1 over f prime of g of x. So we have 1 over f prime of g of x, and here we have the square, and here we have f double prime g of x divided by this term, that is f prime of g of x. Now if these two terms get multiplied, so here we have minus f double prime minus f double prime of g of x divided by f prime of g of x, and here the power is 2, and here we have the power 1, so this is the cube, right? So the second derivative of g of x can be given by this expression also, minus f double prime g of x divided by the cube of f prime of g of x. So viewers, this is how we have derived the expression for the first derivative of the inverse function and the second derivative of the inverse function. So the first derivative can be obtained by using this result, that is g prime of x is equal to the reciprocal of f prime of g of x, and the second derivative of g of x can be obtained by using either this result or this result or this result, right? So now let us find out the values of these two expressions using these results. So now we'll utilize these two expressions to get the value of g prime of 43 and g double prime of 43. So now g prime of 43 is obtained by this expression by replacing x by 43. So we have 1 over f prime of g of 43, right? So now we have to find out the value of g of 43. So for this, what we will do, will make use of the function. So we have y is equal to 9x square plus 6x minus 5, right? Now see here, we have a g of 43, right? So it means here we have y is equal to 43, and the image of x under f is y, and we have to find the values of those x for which the image of 43 under g is x, right? So for this, what we will do, will take y is equal to 43. So now we have 43 and 9x square plus 6x minus 5. And now we have to solve this quadratic equation. This is 9x square plus 6x, and we have minus 48 is equal to 0. And now dividing throughout by 3, we can now write 3x square plus 2x, and here we have 16. Now splitting the middle term, we can easily solve this equation. So we have 3x square. Now 3 times minus 16 is minus 48. So we have the two factors as 8 and minus 6. So we can now write 8x minus 6x, which is 2x, and 8x times minus 6x is minus 48x square. So here we have minus 16. Now grouping the terms, we have here we can take x common. So we have 3x plus 8, and here we have 2. Then we can write 3x plus 8 is equal to 0. So this is x minus 2 and 3x plus 8. So this is equal to 0. So from here, we can now write x is equal to 2 and x is equal to minus 8 over 3. Now see, x belongs to the set of natural numbers. So here we can discard this value of x, because this does not belongs to the set of natural numbers. So we'll retain only x is equal to 2, because x is equal to 2, it belongs to the set of natural numbers. So now we see that for y is equal to 43, we have got x is equal to 2, right? So it implies that f of 2 is equal to 43, or in other words, g of 43 is equal to 2, because the inverse of f is given by g. So from here we can also write 2 is equal to f inverse 43, and f inverse is given as g. So we can write 2 is equal to g of 43, which is same as this expression. So now substituting g of 43 as 2. So here we can now write g prime of 43 is 1 over f prime of 2, right? So now we have to find the derivative of f at x is equal to 2. So let us differentiate this function. So we can now write f prime of x as d by dx of 9x square plus 6x minus 5. So here the derivative of 9x square is 18x, and here we have simply 6. So f prime of x is 18x plus 6, and we can also find out the second derivative, because we need the second derivative while finding out the second derivative of g of x. So the second derivative of f of x is simply 18, right? Because the derivative of x is 1 and the derivative of 6 is 0. So now f prime of 2. So we can now find f prime of 2 by replacing x by 2. So we have 18 times 2 plus 6. So this is 36 plus 6, that is 42, right? So here we can substitute the value of f prime of 2. So we have 1 over 42, right? So where's the value of this expression g prime of 43 is given by 1 over 42. So now to get the value of g double prime of 43, we can now write with the help of this expression minus, and here we have the second derivative of f at g of 43, and in the denominator we have f prime of g, and here we have 43, and here we have the cube, right? Okay, so now g of 43 is equal to 2. So we can now write f double prime, and here we have simply 2, and here we have f prime, and g of 43 is 2, and here we have the cube, right? So now f double prime of 2 can be obtained from this expression. Here f double prime of x is 18, which is constant. So f double prime of x is independent of x. So f double prime of 2 is simply 18. So we have minus 18 divided by here we have f prime of 2, and f prime of 2 is 42. So here we have 42 cube. So now simplifying it, we have minus 18 divided by 42 times 42 times 42, and we can cancel it. So we have 6 times 3, 18, 6 times 7, 42, and here we have 3 times 14. So we have a minus 1 in the numerator, and here we have 42 times 14 times 7, and if we multiply all these three numbers, we'll get minus 1 over 4116, right? So viewers, the value of g double prime of 43 is given by minus 1 over 4116. So this is how by making use of these two important results, we can find out the first derivative and the second derivative of the inverse function of f of x at the indicated point, and the indicated point is x is equal to 43.